Okay, so today we're doing Big Ideas section 10.4, which is 0 and negative exponents. Our objective is I can apply the properties of exponent operations. Okay, and so today we're learning the 0 and negative exponent properties, okay, or rules. Okay, so you might see the word rules instead of exponents, okay? So the 0 exponents rule is for any non-zero number a to the 0 is 1, which you should remember that from your activity, okay? The power 0 to the 0 is undefined, okay? Okay, so in numbers, if I have 4 to the 0, that equals 1. And in algebra, if I have a to the 0, that also equals 1. So anything to the 0 power is 1. Anything to the 0 power is 1. Okay, that doesn't mean it's a to the 1. That means it equals 1. Okay, is 1. Like, takes the number 1 takes the place of that, the whole thing, not just the 0, the whole thing. Okay? Okay, the negative exponents rule is for any integer n and any non-zero number a to the negative n is the reciprocal of a to the n. Okay? So in numbers, that means if I have 4 to the negative 2, that's the same as 1 over 4 squared. Okay, because the a to the n, okay, so if my exponent is negative 2, that means n is 2, okay? So a to the n would be 4 squared, and then the reciprocal would be 1 over 4 squared, okay? Which is that. Okay, so in algebra, that means that a to the negative n is equal to the reciprocal of a to the n. Okay, so the reciprocal of a to the n is 1 over a to the n. Okay, and hopefully you remember learning that or experiencing that in the activity. Okay, so this says using only positive exponents and then evaluate the expression. So not only does it want me to write it using positive exponents, but it actually wants me to evaluate, not write it as a power. So write it as a power and then evaluate. Okay, because that's me saying I don't want you to just type 3 over negative 4 into your calculator, or 3 to the negative 4. Okay, so the a to the n on this would be 3 to the 4th, and then the reciprocal of that is 1 over 3 to the 4th, okay? Well, so there's writing it using positive exponents, okay? And then 3 times 3 times 3 times 3 is 81. Okay, so that would be 1 over 81. So both of those, here's my writing it using only positive exponents, here's evaluating. So we need both, okay? Okay, so this is, these are both hold on just a second. Okay, so one of these is supposed to be negative. It doesn't really matter which one you do. I wanted to go make sure before I changed it. Okay, so that's supposed to be negative. So if I do that, I'm going to add negative 4 plus 4. So negative 8.5 to the negative 4 plus 4. Well, negative 4 plus 4 is 0. So negative 8.5 to the 0 is just 1. Because anything to the 0 power is just 1. Okay? Okay, this one, okay, I would subtract 6 minus 8. So you still have to do the numerator minus the denominator. You can't change it just because you know it's going to be negative. Okay, so that gives me 2 to the negative 2nd power. Okay, so then my a to the n would be 2 squared. Okay, so up here I'm thinking back, my a to the n would be 2 squared, and then the reciprocal of that is 1 over 2 squared. So there's my writing it using positive exponents, and then I need to evaluate it. So 2 squared is 2 times 2, which is 4. Okay, so those are the two that I'm looking for. Okay? Okay, go ahead and do these U-tries. Okay? There's a couple more here too, 4, 5, and 6. Okay? Okay, next examples. Okay, I have negative 5x to the 0. Okay, well, anything to the 0 power is 1. So that means I have negative 5 times 1. Well, negative 5 times 1 is just negative 5. Okay. Okay, and then this one over here, I have that 9. The 9's going to stay because there's no negative or anything on it in the exponent. If it was negative 9, it would also stay in the numerator. The important thing to remember here is we're not looking at the sign of the number. We're looking at the sign of the exponent. Okay, so just because a number itself is negative doesn't mean we do the reciprocal. Okay, so like over here, I didn't do the reciprocal of negative 5. Okay, negative 5 stayed. Okay. Okay, so now I'm going to simplify this. So I have y to the negative third minus 5, because I subtract. Okay, so that's y to the negative 8. And the reciprocal of y to the negative 8 is y to the 8th. Okay. Oops, 1 over y to the 8th, I'm sorry. Okay, so now I have 9 times 1 over y to the 8th, which just simplifies to 9 over y to the 8th, like that. Okay, because this is 9 over 1, so 9 times 1 is 9. 1 times y to the 8th is just y to the 8th. Okay? Okay, go ahead and answer this one. Okay, water leaks from a faucet at a rate of 50 to the negative second liter per second. How many liters of water leak from the faucet in 1 hour? Okay, so the first thing I'm going to need to do is figure out how many seconds are in an hour. So I know that 1 hour it equals 60 minutes. Okay, and so 1 hour is 60 minutes. Okay, and then I know that 1 minute is 60 seconds. Okay, so I'm going to multiply straight across. So 1 times 1 is 1. So think of it this way. If I had like 5 and 5, I could cancel those out. So I have minute and minute, so I can cancel the minutes out. So the minutes goes away. Okay, so then 60 times 60 is 3,600. So I have 1 hour is 3,600 seconds. Okay, so 1 hour is 3,600 seconds. So for 1 second, it's 50 to the negative second. So 50 to the negative second is the same as 1 over 50 squared. Okay, so 50 squared is 2,500. So I have 1 over 2,500. Okay, liters per second. Okay, and I know that there's 3,600 seconds in a minute. So I'm going to multiply, or in an hour, so I'm going to multiply this number. So I have 1 liter per 2,500 seconds. Okay, and I know that there's 3,600 seconds in 1 hour. And so I'm trying to figure out how many liters per hour. So I want liters over hour. So if I look at this, if I cancel out seconds, okay, do I have liter per hour? Yeah, I do. So this is what I want to evaluate. So I have 1 times 3,600, which is 3,600, and 2,500 times 1, which is 2,500. Okay, so now I need to divide 3,600 divided by 2,500, 1.44. Okay, so 1.44 liters per second. Okay, and I just did capital L for liters. If you do little l, that's for length. Okay. Okay, so now you're going to do it if this is the rate it leaks. So your 3,600 is the same because there's still the same number of seconds in an hour. We're just changing the rate at which it's leaking. So this is the number that's going to change. Okay? Okay, go ahead and do that. You try.